So the next thing we're going to look at z-scores in context and calculating our z-score. And the nice thing about z-scores, they enable us to compare observations in one group to those in another, even if the two groups are measured in different units or under different conditions. Right? So the idea is here, in a way, it's kind of similar to what we think about with percentages. Right? We know that a 95% on a test is a good score. Right? It doesn't matter if the test is a 30-point test or a 200-point test. Right? We can use percentages to kind of compare those two different values. That's the same idea of what we're going to do with z-scores. We're going to be able to compare our observations from one group to those in another, even if our units of measurement or the number of points of a test or something along those lines are slightly different. All right, so as far as our formula goes for calculating our z-score, we're going to find the difference of the observed value and the mean divided by the standard deviation. Z-scores should almost always be rounded to the nearest hundredth place, which means 2 decimals. Right? So in our notation that we've used so far in this chapter, our z-score is going to be x, that's our observed value, minus x bar, which is our mean, divided by our standard deviation. And I went ahead in this little formula and put parentheses in the top part to remind us that if we're plugging this into our calculator all in one step, we want to use parentheses. If you want to do it in 2 steps, that's fine. Do your subtraction first and then do your division. All right, so we're going to go through an example calculating our z-scores and comparing these, actually a couple of examples using our z-scores in context. So that's what we're going to do next. So Maria scored 80 out of 100 on her first stats exam and 85 out of 100 on her second stats exam. On the first exam, the mean was 70 and the standard deviation was 10. On the second exam, the mean was 80 and the standard deviation was 5. All right, so first we're asked to calculate Maria's z-score for each test. All right, so for our first test, we're going to take our observed value, which is what she got on her exam. So she got 80 on her first exam, minus the mean of the first exam. So we have 80, mean of first exam was 70, divided by our standard deviation was 10. So 80 minus 70 gives us 10. 10 divided by 10 gives us 1. And then oftentimes we still write z-scores with 2 decimal values, so I'm just going to write it as 1.00. All right, then for Maria's second test, she had an 85 minus the mean was 80, and the standard deviation was 5. We get 5 out of 5. 5 divided by 5, still 1.00, right? Divides evenly to give us 1. So then this question asks us, on which exam did Maria perform better when compared to the whole class? And we are going to say neither. Since the z-scores are exactly the same, she did equally well on both exams. Right, when compared to the whole class. So granted, her score was a little bit better on the one, but based on the mean of the class and the standard deviation, the z-scores turned out to be exactly the same. So the comparison is the same for both of these. Right. Now we're going to look at one more example at the bottom of the page, kind of doing the same thing. So we're going to go through, we're going to calculate a couple of z-scores. So suppose road A had a mean speed of 60 with a standard deviation of 5 miles per hour. Just a little tiny typo in there that should say A instead of an S. Road B has a mean speed of 60 miles per hour with a standard deviation of 10 miles per hour. Suppose the driver travels at 70 miles per hour on each road. Calculate the z-score for each road. All right, so our observed value is going to be 70. minus the mean on road A is 60 with a standard deviation of 5. 70 minus 60 gives us 10. 10 divided by 5 gives us 2.00. Right, road B, still supposing a driver travels 70 miles per hour. Mean is also still 60, but here we have a standard deviation of 10. 70 minus 60 gives us 10. 10 divided by 10 gives us 1.00. So is a driver going 70 miles per hour on road A traveling relatively faster or slower than a driver going 70 miles per hour on road B? Well, in this case, we are going to say faster. Right? It's going to be faster because this z-score is higher than that one. Right? So since the z-score on road A is higher, a driver traveling 70 miles per hour on road A is driving relatively faster than road B because of our difference in z-scores. Right, so z-scores in context and doing our calculations, right, this gives us a way of comparing two different values from two different scenarios and then doing some analysis based on those comparisons.